Hello. In this class, we'll explore break-even analysis. In this topic, there are a lot of terms. In order to understand those terms, we need an example. Let's start with $100 that will be a selling price for some item. So S will be the selling price of some item, which is $100. Assume that this item has what we call variable cost, $90. And variable cost is what we spend in order to make that sale possible. So, for example, if that $100 is a chair that we sell, then $90 could be materials that we spend to make that sale possible. And the reason it is called variable cost is because the more items we sell, the more cost we will incur. If we sell 2 items, we'll collect $200 from our customers, but we'll spend ourselves $180. Therefore, we call it a variable cost. Assume that in our store, we also have a fixed cost. And let's say that fixed cost is $1,000 per month. So what this fixed cost is, it could be the rent for the facility that we use to sell our products. And the reason it is called fixed cost is because it doesn't change whether we sell 1 item or we sell 1,000 items that month. Let's say it's per month. This fixed cost will not change depending on the number of items we sell. Therefore, we call it fixed cost. Here we go. That's a very simple example that we start with. We sell some item for $100. We spend ourselves $90 to make that item sale possible. The more items we sell, the more cost will incur. So that's why it's called variable cost. And also we have fixed cost, which is $1,000 per month. And that could be rent for the store. And that is called fixed cost because this amount doesn't change whether we sell 1 item or we sell many items. It will always be our cost, which means that if we don't sell any item, we will be $1,000 in loss. So the question arises now, how many items should we sell? How many items should we sell to break even? In other words, how many items should we sell in order to pay off our fixed costs? Well, let's use letter N to speak about the number of items to break even. And from this example, you can understand that it will be $1,000 divided by $10. Let's understand why. So $1,000 is your fixed cost. That's what you need to pay off in order to break even. And 10 is what we call contribution margin. This 10 we will call contribution margin. This contribution margin is calculated as selling price minus variable cost. In this case, contribution margin is calculated as 100 minus 90, it is 10. Why it is called contribution margin? Because every time you sell an item, you make $10. So this $10 contributes towards paying off your fixed cost, and then after you pay off your fixed cost, this $10 will be contributing to net income. That is to pure profit that we make. In this example, fixed cost is $1,000, and every time you sell a product, you make that contribution margin $10, which means that you need to sell 100 items to break even. If you sell 100 items, you will break even. Every item you sell, you make $10. If you sell 100 items, you make $1,000, and you use that $1,000 to pay off your fixed cost. At that time, you break even. Well, This simple example shows that every time when you want to break even, what should be happening is that your total revenue should be equal to your total cost. Total revenue is calculated as the number of items you sell times selling price of each item. Total revenue is the amount of money you collect from your customers when you sell n items. And total cost is calculated by using the same number of items that you sell, which you will multiply by variable cost for each item, and then you will add fixed costs. So total cost is N times VC, which is in itself total variable cost. We can call this total variable cost plus fixed cost. In fact, it is very easy actually to understand. So you break even when your total revenue is equal to total cost. That is to say, whatever you collect from your customers is equaling whatever you pay for your products and as well for your fixed costs. So when there is this equality, you break even. Total revenue is the number of items you sell times price per each item. That's the total money you collect from your customers. And N times VC represents total variable costs, so that these are all variable costs for all items that you sell, plus fixed costs, the amount of money you have to pay regardless of the number of items you sell. You see, if we clarify this equation using our example, you break even at some number n, you will multiply by $100, that's the price per item. That should be equal to this number of units you sell times variable cost. So in this case, variable cost is $90 plus fixed cost is $1,000, right? So in this example, this relationship will be written as in this fashion, right? So, and n here is the break-even number. N here is break-even number. Of course, as our previous arguments showed, n is 100 items here. And you will now see that when you break even, it will be 100 times 100 equals 100 times 90 plus 1000, right? So 100 times 100 is 10,000, and 100 times 90, that's your total variable cost, will be 9,000 plus $1,000 that you have for your variable cost, and it's also $10,000. So total revenue equals total cost at the break-even number of units. It's important to understand that total revenue is equaling to total cost at the break-even number. So it's not always that total revenue equals to total cost. It's only at the break-even number of units, total revenue will be equaling to total cost. And to clarify this relationship, you can use this example and analyze it. Okay, this way. In general, though, we can speak about a more general relationship, which will be this. We can speak about relationship which is total revenue equals to total cost plus net income. This relationship will work regardless of the fact whether you break even or not. But you will break even when net income is equal to 0. So when there is no net income, which is there is no pure profit for you, then you will break even. But in general, total revenue is going to be total cost plus net income. And this relationship will be in more detail written this way. So if you sell X number of items, not necessarily N, so we used N before to use break-even number of items, but now if you sell some number of items X, total revenue will be that number of items times S, which is your selling price. It will be X times variable cost, so you will incur variable cost when you sell that X number of items, plus fixed costs, right? So all that will represent total cost, and then it will be also plus net income. So no matter what number of items you sell, you always will have this relationship happening. If you don't sell enough items to make net income, that net income actually will be negative, which means that it will be a loss. And if you sell more items than you break even, then net income will be positive, and that will be your profit. But if you sell exactly the number of items to break even, net income will be 0. Now, we will explore this topic further using examples when things will become clearer, of course. So let's go ahead and check out our first example. The variable cost of each item is $45 and the selling price is $63. If the fixed costs are $1,500 per month, how many items must be sold per month to break even? What is the break-even revenue? Well, in this problem, let's analyze that we have variable cost of each item. So when we sell every item, there is a cost of $45, right? So let's write it down. Variable cost is $45. And the selling price in this example is $63. So that's how much the store sells each item for. So selling price is $63. Fixed costs are $1,500. Fixed costs are $1,500, which could be a rent or something which doesn't depend on the number of items we sell. Well, there are two ways to solve this problem. And it's important to understand those two ways. So the first way to solve this problem is to say that break-even number n, and we do need to find break-even number here, right? So how many items must be sold to break even? So this number of items to break even, we'll use letter n to denote. So this number of items is your fixed cost divided by contribution margin. That's because this relationship shows how many times contribution margin fits into the fixed cost. And that's exactly what will be happening when we break even. So what is the fixed cost? It's 1,500. And what is the contribution margin? Contribution margin is the difference between selling price and variable cost, right? So let me write it here somewhere. Contribution margin will be selling price $63 minus $45. So contribution margin is $18. We will use this $18 right here. Therefore, we find N is 83.33. But we cannot sell 83.33 items unless this item is something which we can split into smaller parts, such as if that item is, let's say, a kilogram of wheat, then probably we could sell 83.33 kilograms of wheat. But if these items are not divisible, so then we will be talking about 84 items. So what we'll be doing, we'll round this number up and we'll say that it's going to be 84 items. So we will break even when we sell 84 items. And once again, what that means that as soon as we sell 84 items, we'll pay off this fixed cost, which is $1,500. Every sale will give us contribution margin, $18, and this $18 will go towards paying off our fixed costs. And this relationship here exactly shows that 18 fits into 1500 83.33 times, and we rounded up to 84 items. So when we sell 84 items, we pay off that fixed cost, $1,500. Another question here is, what is the break-even revenue? Break-even revenue. So this word revenue means amount in dollars, and break-even revenue means the amount of dollars that we have to process in order to break even. Well, we already found 84 items here, so break-even revenue is 84 times selling price for each item, which is 63. It will be 5,000 to 5,292. In other words, when we receive from our customers $5,292, we will break even. And this $5,292 is what we call break-even revenue. Pay attention that this break-even revenue here is dependent on this rounded up number of items, which is 84 number of items. Once again, this is unless the product you are selling is divisible. And if that is divisible and it is possible for you to sell a fraction of that product, then it would be making sense to use this unrounded number. Well, let's speak about another way to solve this problem. So we used this more simple way to solve this problem, but another way is also important because of two reasons. First of all, it is important because it will show the application of the relationship, which is total revenue should be equal to total cost at the break-even number. And also it is important because it teaches you how to solve problems which could be only solvable using this relationship. Well, total revenue should be equal to total cost at the break-even number. So let's assume that the break-even number is n. So we have some break-even number n, which we don't know yet, that we will use to build this relationship, total revenue equals to total cost. Well, total revenue is going to be n times selling price for each item, and in this case it's $63. That should be equal to total cost, which is again n, that break-even number, times $45 is your variable cost, so times 45 plus your fixed cost, which is $1,500. So that's the relationship, which is total revenue equals total cost when you have break-even number of units. So whatever you take from your customers, n times $63, that's the amount of money you take from your customers, that should be equal to the amount of money you pay yourself every month, right? So, and here, pay attention, how many items must be sold per month to break even. So here we talk about monthly break-even number, right? So this relationship here is only also monthly relationship. So every month you take this many dollars on the left side, that's your total revenue, and on the right side you have your total cost per month. Now let's solve this equation. We move all unknowns to the left side, n times 63 minus n times 45, and on the right side, we have 1,500 left. We will factor out n, and here we go. So n times 18 equals 1,500. From here, you will find n, which is 1,500 divided by 18. And you're back to that original situation, 1500 divided by 18, which will result in 83.33, and we use the same logic to round up to 84, and then we can find break-even revenue as well. So in the second way to solve this problem, we used this total revenue equals to total cost relationship, which is valid at the break-even number, and we solved for n, for this break-even number. That's another way to solve the same problem. Let's explore this topic further using the next example. Alpha Cameras pays rent $4,500 per month. The store also has $500 electricity bill every month. If each camera they sell for $780 has the cost of $509, how many cameras must they sell to make the net income of $7,000 per month? Well, again, let's analyze this example carefully. So we have fixed cost, which is $4,500 because that's rent. No matter how many cameras they sell, they will still have to pay this rent. So fixed cost in this case is 4,500. However, you need to pay attention that every month they also have to pay electricity bill, which also is independent on the number of items they sell. Therefore, we need to make sure that we add this $500 to that fixed cost. Therefore, our fixed costs for this example are $5,000, and that's per month. It is always important to keep in mind for what period we're given information here. So fixed costs are $5,000 per month. Now, they sell each camera for $780, which means that selling price is $780, and cost of each item, which is variable cost in our example here, is $509. The question is, how many items should be sold to make $7,000 per month for net income? You see, so here what the question is asking is the net income, the amount of money you make after you pay your fixed costs. Again, let's use two ways to solve this problem. In the first way to solve this problem, let's use this letter X because we used letter N for the break-even number. So this letter X will denote the number of items to be sold to make that net income of $7,000. Well, that X is this. So first you need to pay for your fixed costs, right? So your fixed costs must be paid. But after you pay your fixed costs, you also need to pay your net income, right? So fixed costs and net income together must be paid by selling those items. Therefore, you need to divide the sum fixed cost and net income, you divide that sum by contribution margin, right? So in this formula is actually very simple to understand. So you're asking how many times contribution margin fits into fixed cost and net income together. Well, X is fixed cost plus net income. So your fixed costs are $5,000 and net income that we're looking for is $7,000. Well, we have $5,000 plus $7,000. We divide that by contribution margin. In contribution margin here is $700.80 minus 509 because contribution margin is selling price minus variable cost. Okay, so let's compute that. It's 44.28. Again, we have to round this number up, and that's going to be 45 items, 45 cameras. What about another way to solve this problem? Now, another way we'll use this relationship, which is total revenue should be total cost plus net income. Remember, we're not talking here about break-even number. That's why we do have some net income happening here. So the general relationship is total revenue is total cost plus net income. So let's say we again are looking for the number of items to be sold for this relationship to be valid, and that's going to be X, this number of items. So you sell each camera for $780. So total revenue is X times 780. That's the amount of money you take from your customers. Your total cost is your total variable cost, which is, so you sell X items, you multiply that by 509, so that's your total variable cost, plus your fixed cost, which is $5,000, plus your net income, which is $7,000. And again, just for training purposes, I'll let you know that X times 509, it's total variable cost, right? So this total variable cost plus fixed cost is your total cost. So this is net income, and this is here total revenue. Again, we will be solving this equation the same way. We'll be moving unknowns to the left side. So it's X times 780 minus X times 509, and that will be equal to the knowns on the right side. So 5,000 plus 7,000 is 12,000. That stays there. You factor out X, 780 minus 509 equals 12,000. And X, therefore, is going to be 12,000 divided by 780 minus 509. So that will be exactly the same number as we already had here. It's 44.28. If we round up, it will be 45 cameras, right? So exactly the same answer, but it is going to be a different solution, which is of course equivalent. I'll just write here just for completion 28. So it's 45 cameras. Okay, so let's proceed to another problem. What is the variable cost of each chocolate bar if the following is known? The fixed costs are $500 biweekly, each chocolate bar is sold for $4.5, and the store has to sell 7,000 chocolate bars to make $10,000 of annual net income. We should notice here that the fixed costs are given as biweekly amounts. However, the net income here is given as an annual amount. Therefore, we'll start by converting $500 biweekly into annual amount. So fixed costs are $500 times 26, because there are 26 biweekly periods in 1 year. It's going to be $1,300 per year. In this problem, we don't know the variable cost, so we need to find the variable cost. Let's build that relationship. So we sell 7,000 chocolate bars. Let me remind you the relationship that we're talking here about. So this is a ratio which is fixed cost plus net income divided by contribution margin. Again, we are asking ourselves how many times we fit contribution margin into fixed costs and net income together. We know that we should sell 7,000 chocolate bars to make that net income. Therefore, X is 7,000. Fixed costs, we already calculated in annual terms, it's $13,000, plus net income $10,000, and contribution margin is the difference between selling price, which is 4.5, and variable cost, which we don't know. So from this equation, we need to find variable cost. So how do we solve that equation? Well, $7,000, we'll multiply both sides of this equation by the denominator here. So 7,000 times 4.5 minus VC, and that equals to 23,000. From here, we'll be opening up this bracket, so it's 7,000 times 4.5 minus 7,000 times VC. It's going to be 23,000. Finally, solving this equation, we can find that its VC is going to be 7,000 times 4.5 minus 23,000 divided by 7,000. We just use some algebra here to find this VC, and it's going to be equal to 1.21. So variable cost is $1.21 in this problem. Well, the same problem could be solved if we call this again way 1. We can solve the same problem in another way, which is using total revenue equals total cost plus net income relationship. Total revenue is 7,000 items that must be sold times $4.5 per item. So chocolate bar is $4.5, and there are 7,000 chocolate bars that needs to be sold in order to make that net income. That is going to be total cost, which is, again, we sell 7,000 items times variable cost, and variable cost we don't know, plus fixed cost. And the fixed cost is $13,000 per year, plus net income, and net income here is $10,000. we have here $10,000. By the way, here I made a typo, so it's 10 needs to be added here, but the calculation was correct. Now we need to solve for this VC. VC is 7,000 times 4.5 minus 23,000 divided by 7,000. And you can see that it's exactly what we already did. So it will be 1.21 is the variable cost. Again, this problem can be solved by another way using that main relationship. And you can select whatever way works better for you, but they are more or less equivalent in difficulty. Let's proceed to the next problem now. Find the annual break-even revenue for the following business. The fixed costs are 1,200 per week. The business buys each product for $23, spends $10 to modify the product, and then sells each modified product, adding contribution margin 14% of the variable cost. Let's analyze this problem. We have here break-even volume that we need to find for year, right? So it's annual break-even volume that we need. However, the fixed costs are given per week, and we also keep in mind that the business buys each product, so it's a cost, of course, variable cost 23, but also there is $10 charge to modify the product. So in fact, we should be careful that variable cost will be the sum of 23 and $10. Okay, so let's now start by first converting the fixed costs into the annual amounts. So fixed costs in this problem will be 1,200 times 52, because there are 52 weeks in 1 year. 62,400. 62,400 for the fixed costs, and that's per year. What about variable costs? So the business buys each product for 23 and spends $10 to modify the product, which means that variable cost will be 23 plus 10, which is $33. Then we read that the contribution margin is 14% of the variable cost. So contribution margin is going to be 33 times 0.14 for $4.62 for the contribution margin. And let's find selling price too. Selling price is going to be 33 plus 4.62, which is going to be 37.62. Well, with this in mind, we can actually answer this question. What is that break-even revenue? In order to find the revenue, let's first find number of items to break even. And number of items to break even is going to be your fixed costs, which are 62,400 per year, divided by the contribution margin, so 4.62. 13,506.5. Well, again, we will round this up to the next whole number, and this will be 13,507 items to break even. products. Revenue, break-even revenue. So let's break-even revenue is going to be 13,507 items to be sold to break even, and we multiply by the selling price of each item, $508,133.34. That's the answer. That's the break-even revenue, which is the amount of money that the business has to receive from customers for the products in order to break even. Let's proceed to the next problem now. The problem reads, a shop produces and sells chairs. The production capacity of the shop is 5 chairs per day. The rental expense for the production facility is $5,000 per year. If each chair is sold for $70 and it costs $35 to produce each chair, at what percent to capacity will the store break even? We have here what we call capacity, which means that that's the number of chairs that that shop is able to produce every day. So we will assume that this store works 365 days per year. And because we are given here annual amounts for the rental expense, that is for the fixed cost, and we are asked here for the break-even number, so we can go to the annual numbers to make sure that we have the correct comparison. So 5 chairs per day is, let's calculate capacity. For the year, it's going to be 5 times 365, so 1,825 chairs per year. This shop can produce 1,825 chairs per year. Now, each chair is sold for $70 and costs $35 to produce it. Well, it means that the contribution margin is 70 minus 35, which will be $35. And now we are ready to find break-even number. So the break-even number is going to be the fixed cost, which is in this case $5,000, right? So that's the rental expense, $5,000. That fixed cost divided by contribution margin, which is $35. We have 142.86 chairs. As always, we'll round this number up to 143 chairs per year. Well, from the previous problems, we already know how to find this n, so I'm not being very detailed here, but it's clear how to find it, I hope, from the previous discussion. Now, we have this capacity 1,825 per year, and we know that this shop would break even at 143 chairs per year. Now, what percent to capacity does this store break even? So percent to capacity to break even is going to be 143 divided by 1,825, and the answer is 7.84%. 7.84%. That's a very healthy number for the business. So what this means is that the business breaks even at 7.84% to capacity, and they have a lot of potential still to make their net income. Actually, this capacity notion is very important for any business, because sometimes no matter how much profit you can be making by each sale, but you're always limited by the capacity. And it's always very interesting to know what percent to capacity you break even, so that it would be possible to estimate, is your business healthy? So for example, in this case, 7.84% to capacity is pretty healthy number. But if you break even, let's say at 99% to capacity, that's a very bad number, because it means that you don't have too much opportunity to make any money. You barely break even. All right, let's proceed to another problem. What is the annual break-even revenue if the annual fixed costs amount to $50,000, total annual variable costs are $40,000, and total annual revenue is $250,000? This problem is interesting because we do not know what exactly the products are. We only know the total numbers. As it is the case usually in business, we could sell a lot of different products, and we would usually operate with total numbers in order to find out some calculations such as break-even revenue. Well, in this problem, because we don't know exactly what the products are, let's find out the cost of each dollar of sales. So let's post this question. What is the variable cost? What is the variable cost of each $1 of sales? In other words, it doesn't matter what I sell, but I can ask this valid question. How much money should I spend to make $1 of sales possible? And how much dollars should I spend in terms of variable cost to make each $1 of sales possible? What is the variable cost of each $1 of sales? Now, in order to find out this, we know that the total annual revenue is $250,000. So I know that I sold $250,000. If I multiply it by the variable cost, I know that the total annual variable costs amount to $40,000. So this is an important thing to understand this equation. I have sold $250,000 in total, but I know that each dollar costs me variable cost to sell. And I also know that total variable costs are $40,000. So from this relationship, I can find the variable cost of each dollar of sales. So variable cost will be $40,000 divided by $250,000. So it's 0.16. In other words, it costs 16 cents to sell $1. Well then, if I know that variable cost, I can now find contribution margin. And contribution margin will be 1 minus 0.16. So I know that I sell $1 and I know that it costs 16 cents to sell that $1. So the contribution margin is 0.84, which means that every time I sell $1, I contribute 84 cents towards my fixed costs and then towards my net income. Now I can find this number n, the number of dollars to be sold to break even. So that's fixed cost divided by contribution margin, and the fixed cost is $50,000 and the contribution margin is 0.84. So n is 59,523.81. I will not round this number up because n here represents the number of dollars. And it's okay if we have 0.81 because we can have 81 cents. To understand this answer a little bit deeper, think about it. This is the break-even number of dollars for this business. After this number of dollars has been sold, the business will start making money, start making that net income. So the total revenue is $250,000. It means that that's how many dollars that business sold. Let's see how many dollars are left to sell in order to make that net income. So that many dollars will be 250,000 minus 59,523.81. 190,476.19. Once again, this number, 190,476.19, is how many dollars the business can still sell to make their net income. But every time they sell each dollar, the contribution margin is 0.84, right? So if we now take 190,476.19 times 0.84, it is going to be $160,000. So the business can still make $160,000 in net income. And if you think about it, that's exactly what must be happening, because in any business, total revenue should be total cost plus net income, right? So total revenue is $250,000 in this business. Total cost is total variable cost, which is $40,000, and fixed costs, $50,000. So total costs will be $50,000 plus $40,000, so it's $90,000. So it's going to be $90,000 plus net income. So net income should be $250,000 minus $90,000, right? So which is $160,000. So as you can see, we have complete match here. Net income from the general structure of this business should be $160,000, and we have it here as well, $160,000. Once again, the answer to the problem is actually this. It's $59,523.81 for the business to break even. And we just verified that this answer makes sense. So after the business breaks even, they still have some number of dollars, which is $190,476.19 to sell in order to make their net income. And because contribution margin is 84 cents for each dollar of sales, they can make $160,000 of net income, and which is exactly what we see here from this general structure of this business. Now, to debrief it all, even though we do not know what products this business are selling, we can ask ourselves the question, what is the variable cost of each dollar of sales? So no matter what they sell, how much does it cost them to sell each dollar of their sales? You can think about this as an averaged out price, this $1. And we found the variable cost of that $1, which appeared to be 16 cents. The contribution margin is therefore 84 cents. And we went ahead and found this break-even number, which coincides with the number of dollars. Well, this finalizes this class, and also this lecture finalizes the course. So good luck to you in your future endeavors. All the best to you, and good luck in your tests in test 3. Thank you so much. Bye, and all the best.